Hello guys, welcome to Code with BK. So in this video we solve the problem to convert a binary string to its corresponding decimal value. So convert binary to a decimal. So we have been given a binary string, okay, of zeros and ones. Suppose 11011. You have to convert this binary string to its corresponding decimal value, okay. So the problem is to find the corresponding decimal value for this binary string, which in this case is 27. So there is a standard method to convert a binary string to its corresponding decimal value. So what is that? We write each bit separately, okay. Since we have to convert from base 2, okay, you multiply it all by 2, okay. Then from the right hand side, start giving power to 2 starting from 0 and increment it by 1 as you go to left. So basically this 2 gets power of 0, this gets 1, 2, 3 and 4, and finally add these values, okay. So 1 into 2 to the power 4 gives you 16, plus 1 into 2 to the power 3 gives you 8, plus 0 into 2 to the power 2 gives you 0, plus 1 into 2 to the power 1 gives you 2, plus 1. So this comes out to be 24 plus 3 comes out to be 27, okay. Let's quickly take another example. If I have 1, 1, 1, 1, okay, so I place them separately, multiply all of them by 2, okay, 0, 1, 2, 3, okay, so this is 8 plus 4 plus 2 plus 1, which comes out to be 15, which is the decimal equivalent of 1111, okay. So we code this exact method into a solution. So I'm going to write a pseudocode func bin to decimal, okay. Takes a string s which contains zeros and ones and returns the corresponding decimal value for this binary string. So I'll make this b instead of s, okay. So in order to calculate this, I am going to iterate this string from the rightmost end, okay, to its left end, because 2 has been given power to 0 for the term which is at the rightmost end. So I begins at the last index of the string. So I starts at length of b minus 1 and goes till the leftmost index, which is the smallest index, 0. So it iterates as long as I greater than equal to 0, and in each iteration I is set to I minus 1, okay. So in this case, okay, I have 1 1 0 1 1, okay, indices 0 1 2 3 and 4, okay. Length of b in this case is 5, okay. I starts here. So for this bit I have to multiply it by 2 to the power 0, okay, which is the bit I get for the first value of I. So I say d is digit at ith index in the binary string, okay. Now ith index in this string is basically a character and you have to get the corresponding digit. So if this character is 1, you have to get the digit 1. If this character is 0, you have to get the corresponding 0. Now it is your implementation in the language that will take care of this. For me, I need to get d, which is digit at ith index in the binary string b. You have to multiply this bit with 2 to the power 0, and the next bit that we will get in the next iteration of I, which is at this index, should be multiplied to 2 to the power 1. So power is increasing as we are iterating from right to left, okay. So I'll start with p, which is basically power at 0. So for the first value of I, d is multiplied with 2 to the power 0, okay. So I'll calculate this as my term m. So I am going to say m is power of 2 to the power p, which is basically 0, okay, and we increment p in the iteration so that for the next bit, which is at this index, p becomes 1, okay. You get this and you have to multiply this m by, which is, this is d, okay. So you get p as d into m, okay, and then you have to sum all these terms. So I'll start with sum as 0, okay, and I'm going to say sum is sum plus this term, okay. So let me just make some space. So we had s is s plus t, our power is incremented by 1 and I moves on to the next index on the left side, okay, and this sum is the corresponding decimal value, okay, which we find by summing all the terms. So you return finally s. So let's drive in this code for this given string. So in this case our b is this string. We start with s equal to 0, we start with p equal to 0, we have I equal to length of b minus 1. Length of b in this case is 5. 5 minus 1 gives us 4. while I greater than equal to 0, I greater than equal to 0, which is 4 greater than equal to 0, which is true. So we go inside the while loop. So D is the digit at ith index in B, and it is responsibility of the implementation to give D as an integer in the ith index in B. So if you get the ith character, this is going to be a character. You need to get this character as a digit. Okay, so you have to convert this 1, which is a character, to a digit. So D is a digit, which is an int at index I, which is basically here right now. So which is this, which is 1. You get M as 2 to the power P. M as 2 to the power P 2 to the power 0 is 1. You get T as D into M. D into M is 1. You do S is S plus T. 0 plus 1 gives me 1. You do P is P plus 1. P becomes 1. You do I minus 1. I becomes 3. Okay. You go back to check for while loop condition. I greater than equal to 0. 3 greater than equal to 0 is true. D is digit at ith index. I is now here. Digit is 1. You get M as 2 to the power P. 2 to the power 1 gives you 2. T is D into M. 1 into 2 gives you 2. S is S plus T. 1 plus 2 gives me 3. P is P plus 1. P becomes 2. I is I minus 1. I becomes 2. You go back to check for while loop condition. I greater than equal to 0. 2 greater than equal to 0 is true. D is digit at ith index. I now comes here at index 2. So you get 0 here for the digit. M is 2 to the power P. 2 to the power 2 is 4. You get T as D into M. D into M gives you 0. Okay, 0 into 4 is 0. S is S plus T. T is 0. S remains 3. P is P plus 1. P becomes 3. I is I minus 1. I becomes 1. You go back to check for while loop condition. I greater than equal to 0. 1 greater than equal to 0 is true. D is digit at ith index. I comes here. So the digit here is 1. You get M as 2 to the power P. 2 to the power 3 is 8. T is D into M. 1 into 8 is 8. S is S plus T. 3 plus 8 is 11. S becomes 11 now. P is P plus 1. P becomes 4. I is I minus 1. I becomes 0. We go back to check for while loop condition. I greater than equal to 0. 0 is greater than equal to 0 is true. D is digit at D of I. I comes here, which is digit 1. Okay. M is 2 to the power P. 2 to the power 4 is 16. T is D into M. 1 into 16 is 16. S is S plus T. 11 plus 16 is 27. So S is now 27. P is P plus 1. P becomes 5. I is I minus 1. I becomes minus 1. We go back to check for while loop condition. I greater than equal to 0 is false. In this case, while loop breaks and you return S, which is the decimal value for this binary string B. So this is how you convert a binary string to its corresponding decimal value. So this was one way, okay, where we have to iterate the string and we have to find the sum. Okay. So there is another method, okay, where we don't find the sum, where we manipulate the bits to get this required value 27. Let's see how. So in this method, we convert this binary string to its corresponding decimal value, okay? But we use bit manipulation in this case. What do I mean by that? So this binary string is 27. So if I have int n equal to 27, okay? In computer science, integers are stored as bits, okay? So this int value has 32 bits. So this exact bit string, okay, is there for the representation of 27, okay? So these are 27 bits, which is basically 27 zeros, okay? And these are the next 5 bits, and these are in total 32 bits, okay? So given this binary string, our job is basically to find an integer value which has this representation of bits, and so we'll get the corresponding decimal value as 27, okay? So how can we do this? Suppose we have x equal to 0, okay? So 0 is basically all 32 bits as 0. So these are 32 bits, okay? And we call the rightmost bit as bit number 0, then bit number 1, bit number 2, and so on till bit number 30th, bit number 31st, okay? So for 32 bits, the rightmost bit is bit number 0, and similarly in this case, 5, 29, 30 and 31, okay? 32 bits. So starting from x equal to 0, which has all bits as 0, we have to reach 1. So what we can do is x equal to 0 is basically 27 zeros and the next 5 zeros, okay? Okay, bit number 0, 1, 2, 3, 4. The indices for this string is 0, 1, 2, 3, 4, okay? But we want this exact set of bits at the right end of this bit pattern, okay? So basically this will be bit number 0, this is index, okay, this is bit number, okay, bit number 0, 1, 2, 3 and 4. So in this x equal to 0, if I want to get this exact pattern, I change the value of bit number 0 to 1 in 0, so bit number 0 becomes now 1. Change the value of bit number 1 to 1, so bit number 1 is now 1. Change the value of bit number 2 to 0, so it remains 0. Change the value of bit number 3 to 1 and change the value of bit number 4 to 1, okay, and the rest of them remain the same, okay. So now this bit pattern becomes the value n equal to 27, okay. So how can we make this conversion? That is, we should be able to convert any bit number I in x equal to 0 to 1, okay, ith bit to 1, and we should also be able to convert ith bit in this x equal to 0 to 0, okay. If we can do this, we can set 0th bit, first, second, third and fourth to the corresponding digits in this string and we get a n as needed, okay. So our task is basically to solve these two on how to set ith bit to 1 and ith bit to 0 in an integer. So when you change the value of ith bit to 1, we say set ith bit, okay, and when we change the value of ith bit to 0, we say clear ith bit, okay. I have written solutions for both these problems separately and you can find the links to the videos in the description. So I'm going to use the pseudocode from that solution to solve this problem and this problem. So let me write the pseudocode for that. So I'll write a function set ith bit, okay, takes in a value n and I, it sets the ith bit in n and returns the updated value of n, okay. I'll write another function clear ith bit, takes in the values n and I, okay, it clears the ith bit in n and returns the updated value, okay. So filling these two pseudocodes from these two problems that I have already solved. So this is the pseudocode for setting the ith bit and this is the pseudocode for clearing the ith bit. So to set ith bit, we start with x equal to 1, we left shift x by I places and then we return bitwise OR of n and x, okay. To clear the ith bit, we start with x equal to 1, we left shift x by I places, we then find the knot of x and finally return the bitwise AND of n and x, okay. You can check out the videos to see in detail how we reach to these solutions, okay. So we iterate the string from right end to left end, okay, because the bit number starts from the right end. We start with x equal to 0 and we manipulate bits in x based on the values of 1 or 0 in b. So if ith bit in b is 1, okay, we set the ith bit. If ith bit in b is 0, we clear the ith bit, and this is the bit number that we count from, this is the index of the string, okay. So writing a pseudocode function to decimal 2, okay, takes the binary string and returns the corresponding decimal value for this binary string. We iterate from the rightmost end. So suppose n is the length of b, I starts at n minus 1, we go as while I is greater than equal to 0, okay, and in each iteration I goes I minus 1, okay. For I equal to 4, which we are starting at the rightmost index, your bit number starts at 0, so I take bit number as 0, okay, and in each iteration I am going to increment the bit number because we are iterating to left from right, okay. So when I goes from 4 to 3, okay, your bit number goes from 0 to 1. Similarly, when I goes from 3 to 2, your bit number goes from 1 to 2, okay. I is decreasing and bit number is increasing as you go from right to left. Then we get d, which is the digit at the ith index in b, okay. Again, it is the responsibility of the implementation to give me a digit as integer at the ith index. So if at ith index I have 1, give me a digit 1 as integer. If at ith index I have 0, give me digit d as integer 0, okay. So if d equal to 1, okay, else, okay. So if d is 1, that is basically bit number bn in this binary string is 1, I have to set this bit number 1 in this x equal to 0. So we also take x which starts at 0, okay, and we set bit number bn to 1 in x. So I say x is set ith bit, I pass x and I pass bit number. Okay, if d is 0, that is if d is 0, that is for bit number bn you have to clear the bit number bn in x. So we say x is clear ith bit passing x and bn, which is basically calling this function to clear the bit number bn in x. Okay, so this pseudocode basically converts x equal to 0 to x equal to the binary string that we are looking for. So x converts to the corresponding decimal value which we finally return. Okay, so this was another method to convert binary to its corresponding decimal value, and let's look at this implementation now. So these are the two methods we used. This is the function that implements the first method where we convert binary string to its corresponding decimal value using while loop, okay, and the conversion method from binary to decimal. Okay, in the second method, this method implements when we are converting binary string to decimal by setting and clearing ith bits, okay, starting from the value x equal to 0, which will eventually hold the corresponding decimal value. And there are certain test cases I have written. So 1111 in binary, 1010, 11011, okay, for the first function, and similarly for the second function binary to decimal 2. So let me run this. Java C, Java. Okay, so for the first three outputs we have 111 is 15, 1010 10, 110 27, and same for the second one. Let me take one more case. Okay, 10010, okay, and passing this Java C, Java, okay, is 34. Okay, and if you calculate 2 plus 32, you have 34. Okay, so I hope this video was helpful. So please do like this video and subscribe to my channel, and please let me know in the comments if there was any part of this which was not clear to you, or if there is a question you want me to solve, or if there is a concept you want me to discuss. Thank you.